there goes the recording. Let's do this. All right. So we're still working on exponential functions. Yesterday we did some exponent stuff just to remind ourselves, and we talked about what an exponential function is. We looked at two graphs. We built tables. When we do transformations and the like, we're not going to do all of those points because there's a chance they all don't fit. Just like a quadratic, you looked for, well, if I taught quadratics, vertex, and then 4 other points. So you had 5 points that you looked at for a sine, curve. A what? What? Oh, okay. But Daddy's trying to teach, so I'm sorry. A trig curve, we had middle high, middle low, middle. Oh gosh, the radical function, we had the vertex and for the endpoint, and a couple to these ones we look at the -1, the 0, the 1, sometimes the 2 if we can fit it. An exponential function will have a horizontal asymptote regardless of where it is. We can transform it. I liken it, even though it's an asymptote and not the same as the sinusoidal axis, but it tells us how far up and down things go. I hope you guys can all hear me. I think so. Okay. Unless it's transformed, it's going to have a y-intercept of 0 and 1. Domain and range. One thing to note, the range is just greater than because we are never going to actually hit 0. Examples of things that have exponential growth are compound interest, but your base is like 1.0 something. Bacterial or viral growth. There was talk when this whole pandemic started. One of the things that was a key kind of indicator was how many days it took for the infected population to double. The states at one point were doubling their population of infected people every 2 days, while Canada never, well, as a country, I don't think got to every 2 days. I'm sure parts of Ontario and Quebec. And then if it doubles every 3 days, it's better. You're better off at 4 or 5. If you're New Brunswick, I mean, we haven't doubled in weeks. And then we have exponential decay, which is a fraction base, which is the same as a negative exponent. Instead, it's just like reflecting it in the y. So it goes from high and down and peters off. It will never actually get to 0. Again, horizontal asymptote. X-intercept is none. Y-intercept, domain and range. And radioactive decay. Cooling, some people think, can be modeled as an exponential function, and we'll talk about that eventually. So I just want to go through something like this. This is something that you could see kind of like a table of transformations. This is new, by the way, sorry, in an assignment. The base, so whether it's increasing or decreasing, where the asymptote is, so this is going to be y equals something. X-intercept, well, I snookered myself there. Y-intercept, domain, and range. Yeah, because we'll talk about that one here in a minute. So if it's 3 is bigger than 1, so that's an increase. As an asymptote, it hasn't been transformed, so y equals 0. Not applicable. The y-intercept is 0. Not then 0, but I don't know why I wrote a 0. 1. X is part of the reals. Y is greater than 0. This one is fundamentally going to be identical. It's increasing. Y equals 0. Changing the base, well, 10 to the 0 is still 0 and 1. This is part of the reals. Y is greater than 0. Oh, that one's decreasing because the base value is between 0 and 1. Y is greater than 0. Increasing, still increasing. This is an asymptote. If we've dropped everything down, this is an asymptote at y equals negative 3. This one is going to have an x-intercept. I tried to get cute and add one because we're going to talk about transformations. An x-intercept is when y equals 0. 0 equals 2 to the power of x minus 3. The unfortunate thing is, as of right now, you do not know how to solve that. And I don't want to show it on the calculator there. I can, but that's because I have more knowledge. To solve for that exponent, you actually need a logarithm. 3. Come on, brain. Where's those buttons? You don't use them on this calculator. This will work. This one has an x-intercept of about 1.6 and 0. Because if I take that's our axis, our asymptote, maybe somewhere down here. So I'm going to have an exponential growth. Well, this is going to be 0, and if that's drop 3, negative 2, which we'll talk about. So 0 and negative 2, and it's going to go up here. So this one has an x or a y-intercept, and now it has an x-intercept. It's still x is part of the reals, but y is greater than, that didn't work out so well, negative 3. So properties of these, we can look quickly if I'm going to draw little mini tables of value to sketch some of these. Well, we're going to set up, why would I do it in all of those? Negative 1, 0, 1. And to sketch it, we know these are going to have that flat and big growth. So 3 to the negative 1 is a third. Well, that's 1. This is 3. So I can do negative 1 and a third, 0 and 1, 1 and 3. And we know that that's going to go up like that. So that's if it's 3 to the x. If it's 10 to the x, negative 1, 0, 1. And technically we could do 2 and get 9, now that I think about it for this one. 2, 3 to the 2 is 9. 4, 5, 6, 7, 8, 9. Yeah, that's okay. Negative 1. 1 over 10. There is a difference there. It's not very big. That's the same. But now this is 10. The next point here, which is going to be somewhere towards the ceiling in my kitchen, would be 100. So we're not going to plot that one. So negative 1 and a tenth is going to be lower than a third. That's the same. But now this one has jumped. This is such, because that still looks like it's, maybe if I go down, something like that. It gets steeper quicker. The 3 to the x would be like tripling every day. The 10 to the x is 10 times. He's playing games on the iPad. Negative 1, 0, 1. This is like a reflection. 1/5 to the negative 1 is 5. 0. 1/5. So negative 1 and 1, 2, 3, 4, 5. They're all passing through there. And 1 and a fifth is somewhere technically between a third and a tenth. Wow, that was bad. Not being able to put the tablet thinger on a table because of space is a pain in the butt. So that's an exponential decay. They all are going to pass through that point because anything to the power of 0 is 1. So far, so good. And we got some more wonderful people. 12 of you. Hi, everybody. If you came in late or just dragged yourself out of bed. I haven't seen Brady in a while. I think he's working. I think he emailed me. What? Oh, I'm going to have to give him such a hard time. Or he's bailed on math. So we're going to look at transformations. We're not going to actually graph anything today. That's in the next section called graphing exponential functions. So we have to be able to identify a couple of things if we're trying to figure out transformations. I saw a kind of y equals a c to the power of bx minus h, and this is c as your base because we use b as the horizontal stretch. So this is the same idea again. F of d. It's just now our f of x is an exponential function. So if we look at this first one, y equals 3 times 5 to the power of x minus 7. Our base function is y equals 5 to the power of x. So I'm just going to start with our nice simple table just so we x, y, negative 1, 0, 1. So just like we did a second ago, a fifth, 0, and 5. So this one has an a value. So the a value is a vertical stretch of 3. There's nothing up in with the x, so this one has a vertical translation of negative 7. Sorry. So where we're going to have to go is the same idea as a mapping rule. X, y goes to. There's nothing with the x, so x goes to x. It's got a vertical stretch, so 3y minus 7. So we can kind of build the transform table of values. Sorry, I made a horrible mistake in here. 1, 5. The x's don't change. Well, I'm going to go from the bottom up. 3 times 5 is 15. 15 minus 7 is 8. 3 times 1 is 3, minus 7 is negative 4. This is the one that's going to get a little bit tricky. 3 times a fifth minus 7. Well, that's 3 fifths minus 7 over as a fifth is 35. Fifths, 3 minus 35 is negative 32 over 5. So the other thing we need to be able to figure out is where the horizontal asymptote is going to be. So our horizontal asymptote for our base function is always y equals 0. Because we've transformed everything down, or translated everything down 7, now we have a horizontal asymptote at y equals negative 7. So we're going to use that when we graph things next week in the same way that we used a sinusoidal axis. When we graphed our trig functions, we knew that where that sinusoidal axis is where we start from, and then we use that as our kind of guide to, well, if we were drawing our trig function, but this we're going to use it as our guide. This is going to be slightly more than negative 7. So this one has a base function. Let's change colors for fun. A half to the x. X, y, 2, 1, a half. So it's not really a huge table. Nothing in front, nothing at the end. So nothing with the vertical. Oh, we've got a negative up with the x. This is a reflection in the y axis. And then we have plus 4, so we have a horizontal translation. And I don't know what was of negative 4. So if we do a mapping rule, well, now if there's a reflection in the y, we have a negative x minus 4, and the y stays the same. So we can build our mapping or a new table if the y stays the same. 2, 1, 1 half. Negative of negative 1 is 1. 1 minus 4 is negative 3. Negative of 0 is 0. 0 minus 4 is negative 4. Negative of 1 is negative 1 minus 4 is negative 5. So this is interesting. Instead of going in an increasing manner, which this makes sense if we're reflecting it about the y, this actually goes back to a function similar to 2. Horizontal asymptote. There's nothing at the end. Come on, brain. Y equals 0. Holy, all sorts of good business. The thing that has the exponent in this case, 4 to the x. So 1 over 4, 1 and 4. Whew. Negative out front, reflect in x. 5 gives us a vertical stretch of 5. We have to do a horizontal stretch, so we're going to take the reciprocal of that is 2. There's no negative out there. Horizontal translation, we switch the sign of 7, and a vertical translation of -6. So this has all sorts of fun stuff in terms of our mapping rule. So horizontal stuff with x, 2x plus 7. Reflection in the x, so negative there with the y. Vertical stretch of 5, y minus 6. That's a doozy. Probably, I mean, graphing these, because we're only looking at 3 points. 2 times -1 is -2. -2 plus 7 is 5. 7. 2 ones are 2, and 9. So that's not that big of a deal. Just because it's going to be a little simpler. Negative 5 times 4 is -20. -20 minus 6 is -26. -5 or -1, or -5 times 1 is -5, minus 6 is -11. Oh dear. Because it's stretched way up. Oh, that quarter. -5 times 1 over 4 minus, well, 6 fours are 24 over 4, -5. -25 over 4. So these numbers look a little bit bizarre. 5. Ben just conned a second bag of the little Ritz crackers and cheese out of Brittany because she didn't see that he'd already had one. So 5 and whatever, -29 over 4 is, oh, horizontal asymptote is -6. So just to sketch this, because this is a little bit different, the horizontal asymptote is way down there, -6. 7 and 11, 9 and 26, 5. This one, because our normal function is here, if I reflect it in the x, it's going to go there, so it's not exponential decay per se, it's just getting more and more negative. So that's what we are going to look at on Monday. Base function, transformations, mapping rule, key points. No, he's not going to eat lunch. Kids are expensive. So that's what we'll do on Monday, and actually sketch some graphs, look at domains and ranges, and then we'll look at modeling a problem with the algebraic side. And that's the plan. That was the plan for today. Does anyone have any questions? Or are we good for the weekend? I don't know how many people have handed in that assignment behind schedule. Whatever, it doesn't matter. I don't care. Everybody good? Ready for the weekend? Be nice to your mothers. Because they're putting up with you like 24/7 when they normally would only be putting up with you like for 2 hours before school and when you ignore them after. So make sure you be nice to your mothers. Yeah.
Thank you.
You're welcome. Have a good weekend.
You too.
Thanks. Welcome. Adios.